Video effects. Yes. So, I argued with you last night. Maybe half of folks gave it a shot, but even those that did it, we seem to have a lot of trouble with number 5. So I want to take some more time looking at it. Another one that I just posted for tonight. Tell me, or better yet, tell Allison if you're on the Discord, how are we? Hopefully 1 and 2 are extremely easy at this point, yes? Any hold up on those, so I can skip those and just move on. Right? Hard to tell because I don't have homework from everybody, so I can't really look at it. I don't know if people didn't do it because they felt like it was too hard, or they just, I don't know. Do what? PhD, you're on the first one, and PhD, 14. Okay. But then on number 3, even though we're still 1 molar, what's the difference about number 3? Concentration is the same, right? Concentration of our acid is 1 molar in each case, but you did not get 0 for Q3, right? What'd you get? What'd you get? 3. Okay, I'm sorry. You got, that's what we did in class. Okay, okay. All right, got it. So, you're saying this one is a little different. What was concentration of acetic acid we had in class? So 1E-2, and this one is 1E0, or it's 1. Okay, so this is a higher concentration for a lower pH, right? Miriam, notice I wrote on one of yours specifically, like, I followed your ice table setup, but I don't know how you got to the pH that you listed. So we need to look at yours specifically. Right, look at yours. Can you see it on your devices? Because I'm wondering, I don't remember off the top of my head now which one it was. One of them was like, no, Miriam's trying here, but I don't know how you get to that number. So I got worried, but your calculator now, you're not using the old calculator, right? Okay, okay. All right, so how would you set up number 3? What would you do? Sadie, what would you do with number 3? How would you start it? You know what it is? Oh. Well, okay, but think back to last week. And you decide if this was pop quiz, here, Sadie, and then how would you start this? Like, oh God, what do we have these? Well, give me any piece, even if it's not the starting or the ending piece. Give me. Okay, so let's say, well, we've got a pKa equal 4.756 must be, and Ka is 10 raised to the negative pKa, so 10 to the negative 4.756, okay? All right, Sydney again, didn't let her overlook yet. What else? So give me another piece, any other piece. Where are we? Stuff. What have we been doing? All right, Alexis, where are we at? You do. You notice this stuff. You do. You try this. Give it a shot. Something.
You can write like the formula. Yeah.
Okay. So, or we can just abbreviate it, right? Like, if you don't care about the acid side. Right? Generalize. I mean, you could have written this as HCH3COO goes to H plus CH3COO minus, but you don't care about that. That acetic, that acetate ion, the A minus. Right, so you can just represent it as A minus, that's fine. All right, somebody else. So that's what you got. What you got? What would you do with this then? Oh, okay, all right, cool. So what do you want me to do? What do you want to, let's see, I'm going to set it up. What do you want me to put in there? Where do you want me to put a 1? Yeah, because we have that known concentration of 1 molar to start with. How about for the H plus and the A minus? I'm going to put zeros, but this is, I'm going to foreshadow a little bit here. One of those is the problem that makes number 5 much more complicated, right there. Here it works, okay? All right, how about the change level? Yara?
To negative X or HCH3 and then positive X for
Okay, good. Yeah. Now what?
what you want to say.
Okay. All right, cool. Mark, what could you do with those? Math. Well, I gotta set it up first before I can math it, right? How would you set it up? The KA thing?
A concentration of negative concentration plus over.
Like this?
Yeah.
Okay. And we can plug in, we've got that KA there, right? So 10 negative 4.756 equals, what's this here? X. And that was X, so we just put X squared on top over HA. 1 minus X, okay, cool. And then math it. Let's put it in Wolfram real quick. So what do we have here? We've got 10 raised to the negative 4.756 equals x2 over 1 minus x. Okay? I'm assuming at this point now that you've done the quadratic and you are capable of doing quadratics, but this will do it a lot quicker than I can. 4.18 e negative 3. So I put it in solver, and you'll see on my, when I upload my version of this, it's just going to say, like double arrow like that instead of solver. And x equals 4.18 e negative 3. Okay, so we map it, like Murph said, right? Carson, what do we do with the mapping of it? We got x.
Yes. Right.
That's going to be concentration. Okay, in this case, it is in fact concentration H plus, right? Then I can just do what with that? Okay, so pH defined as negative log of that. And you get negative log of that, please. 2 what? 2.38. I'm not going to count off for this on an exam, but Owen actually said this directly. Let's look at our problem again, and let's think about sig figs. So how many sig figs do I have in the problem? I've got 2, right? And like I said, this would be upper level stuff that's going to matter later. But when you do a logarithm, the decimal places are your significant figures. So 2.38 is actually correct, because 2 sig figs gives you, this is order, the 2 is order of magnitude, and then the 3.8 is your significant pieces. Don't worry about it. Okay, so we get a pH of 2.38. Yeah? So, that is a medium complicated one for the exam right there. Okay, so 1 and 2 should be super easy ones for the exam, right? This one, medium complicated. So I need feedback on where you stand on this. What's holding you back here, Sydney? Getting to 2.38 pH for this. I mean, that's the kind of question I'm going to ask you is, given this setup, I need to find pH. What holds you back from that being?
Just we have to make practice.
Practice, okay, practice. Yes, Mary.
For me, it's also the same on the last unit, it's the whole like finding phonetics. And I'll have like your K equals and then setup, but somewhere along the way, like I round here.
That is interesting. Do we know where? Can we find it in this case? What did you get to 2.38 in this case?
I got 3.07.
3.07. Let me try to figure out where that could be. So would you take 10 and raise to the negative 3.07? I'm wondering where that round off is happening to you.
8.5 times 10 to the negative 4.
8.5, 10 to the negative 4. So how did you solve for x? Are you doing it on your solver?
Yeah, but so like whenever I bring my bottom bracket,
Yeah. This piece here. That one?
yeah,
Okay. Oh, are you making a simplifying assumption? That that's just one?
that's what I did.
Okay, not that. Okay, well, okay, tell me, you're right here, right? What do you do from here?
So like you bring the bottom bracket to the other side to the equilibrium. You multiply like distribution type.
Okay, so 10 to the negative 4.7 times 6 minus 10 to the negative 4.756 times x equals
Okay,
x2.
I'm in question 5.
Huh?
Maybe that's the problem. I'm in question 5.
Oh, okay. Yeah, that'll be different. All right, no, I'm sorry. All right, what'd you get on this one? Did you get 2.38 on this one?
Yes.
Okay, okay. We're trying to solve the problem. Okay, fine. Okay. All right. What else? Other thoughts on this one? Because I'm going to ask you this, right? On the exam. I should. So, what do you think? That one? Easy? Lori? Yeah? Everybody?
It's just with my problems, so I took a really big and I figured out, okay, what am I trying to look for? And I
Yes.
think I'm getting ahead of myself and I like my own worst critic. So that's
So my advice for you on that is to write a lot of things, right? Because if you end up going off the rails somewhere, but if I can find a piece of it, I don't know the answer to this off the top of my head. I'm honestly asking this. Looking back at your previous 2 exams, does it look like you did better or worse on the multiple choice part than the rest of them?
I think worse on the multiple choice, but
That makes sense.
but with like like full page, it was like find the concentration of this and it gave you the tables. I think because I started to really help me out and more of a one-on-one
And that may be a practice thing too, right? Yes. Oh, and Mercy, before exam two, y'all came to the night class. Was that helpful? So there is a lot more practice going on there, right? Because I assume that they've seen this lecture that we're talking about them right now, and they're going to see that on video, right? And then hopefully, the idea at least is that then after seeing that, they come into class and work together.
Some of you explain things just a little bit different, so it clears up any misunderstandings here and there. It's really possible.
It was not a very big class at all. I think we had 4 last week. Yeah. Oh, y'all are always welcome. Okay, shall we move on then to Q5 here? Yes? All right, I'm going to actually delete all this because I'm going to change bits of it. What do I need to change then to make it work here? Oh, one other thing. I'll write this as F. This is one of the things that needs to change. F equals, what I'm saying here is the initial concentration of my acid, and it was 1 mole in question 4, right? Okay, so that's one of the things that's going to change in question 5, right? My initial concentration is much lower, right? Does that make sense? So I'm going to change it, put this as 4E, what is it? -2. Okay. Now what? Everybody follow what I'm doing here. I'm just changing up our Q4, right? And now what did you do here? Here? Okay. And down here? Does that make sense so far? No? How this is changed as we go here? Yeah? All right, all right. So now, what happens here? What do I do with that? Carson, what do you do with it? Here. So I just use this guy. Or -2 right there. Anything else? Oh, okay, okay. So my pKa to this guy was what? Oh, I just went straight to Ka on this one, huh? Is 3E-8. Okay. Now what? Solver it again, right? Put in solver. Wolfram. So now I've got here, I've got 3E-8. And here, now I'm going to change, well, not yet. I got to change this over here, right? To what, 4E-2? Solver it again. Okay. Don't forget. Let's see what Wolfram thinks our solution is. So it says, what did it get there? 3.46 times 10 to the negative 1, 2, 3, 5. Okay, somebody name log that for us.
4.46.
4 point what?
46.
Different what I got on here, isn't it? Three negative 8, 40 negative 2 minus x. Okay, cool. I'm gonna change that one, I guess. You see the problems? It's right here. That'll work. Which of course you'll have no video anyway, so I guess you don't need to. Okay, so you feel like you could do that, guy? Now, there might be a complication there with the quadratic, right, and actually punching the numbers in and stuff, but if that trips you up, that's very small amount. Does that make sense?
So just do it step by step.
Yeah, definitely good step by step. Okay. All right, tell me where the difference lies. So you have this guy. You have negative 6. Does that match what I had? No, I had negative 8, didn't I? All right, let's look at that.
Multiply 3 negative 8, 5, 4 negative 2, that got me 1.2 equals 11.
Agree with that.
And then I took the square root of that.
Oh, you're doing, okay. So you're doing the square root approximation. Okay. The square root approximation is going to throw you off on the harder problem. So let's take a look at that. It's a good point, Owen. So Owen is taking that Ka equal x squared over 1 minus x, multiply both, but you're assuming here, right, that this is approximately the same as x squared over 1. Because you're thinking if 1 minus x is not significantly different than 1, if x is really small, right? Does that make any sense? So that's the approximation there, right? So then we have 3a equal x squared over 1, x squared, right? Then you just take square root of the sides. Yes? So what did you get here, Owen?
After that, I got 3.46.
That's not square root of that.
No, before that, it was 3 negative 8 times 4 negative 2, which equals 1.2. And the square root.
Oh, this is not 1. That's right. What is it? 3?
4 negative 2.
Okay, cool. Now what's under here?
1.2
And the square root is?
3.46 next 6.
Thank you. Okay, so that's the square root approximation. This is what I was telling Miriam that she should be using on that MCAT, which she doesn't get to use a calculator, right? But we need to check that and see if it works. So let's try it. Let's take this and let's plug in, well, h plus a minus over ha, right? Well, we know that h plus is X, and A minus is X, right? And then our HA is 4E negative 2 minus X. So let's plug in your values and see what we get, okay? So let's see, what is X? It is 3.46 E negative 6, right? Plug it in again. Now, what is 4 times 10 to the negative second minus X? What value would we get for that? This minus what you got for X. 4E negative 2 minus X. Repeat it. 3.996. So what else? What do you get?
I got 0.03.
3 nines? 999 what? Okay. Number of digits?
6.
E negative 2. Okay. Now let's try it. So let's take this guy and square it. Right? And then divide by that number that Carson just gave us. And what do we get? Here, what it was. What'd you get? What'd you get on the top when you squared it? And then divide.
2.99.
What should we have done? Right? That calls into question this assumption. If you actually make the assumption here, the simplifying assumption, so you can do the square root method, you get a value here, right? It doesn't look like it's at equilibrium. It does not look like the Ka over there that we have, right? The 3e negative 8. So that makes me question it. But let me look a little further. What pH does this imply? pH would equal what here? I agree, Karen. 5.46. Okay. Okay, so let's look at that. That is suspiciously off by 1 with the H unit. So depends on your purposes, right? If you're putting together a fish tank, this is kill your fish. If you're on 4.46 versus 5.46, does it? I don't know fish well enough. I'm asking. If somebody in the night class does fish, so it does.
I don't know.
Anybody know fish? Okay, biologist. How about for your cell cultures that you're experimenting with? Does this kill your cells? It does? I don't know that. If we're off by a whole pH unit, I am worried. Right? Does that make sense? So, and I would say in this case, maybe not. Right? Or just do what? Okay. You don't like doing the quadratics? You should practice it. And if you don't like it, that's probably the people that should practice it, right?
Just because it takes so long.
Okay, but I want to check further. Now that we're starting to check things, there's more that we should check. One of our assumptions that we made was that our pure water started with 0. Here. Is that true? If you have pure water and you check its pH, what should it be? Oh, wait. Doesn't that imply that there's a concentration H plus to start with? What is that starting concentration H plus? Right? Well, I don't know. Will that change things? We should check. Right? What does that change in Murph's calculation over here? What would it change here? What would it change in the algebra?
It's different.
Where am I going to change it? On the top, in the numerator. I'm going to change x squared. It's not x squared anymore, right? Because it is 1 e negative 7 plus x times x. See how the algebra gets more complicated, right? And so when that college algebra professor is telling you that you need to complicate what you do, well, let's see what we have here. Instead of just x squared on top, right? What do I have? 1 e negative 7 times x over 4e negative 2 minus x. Yeah, right, let's show that. Let's see if it's any different. You think it will be? That's a lot harder if I was having to put it into his calculator, right? So the numerator now is 1e negative 7 times x plus x2 over 4e negative 2 minus x. All right? Make those math professors happy. Well, probably with visible factor. We'll get here. So this one gets x, which is x plus, no, x is not x plus. X is 9.23 e neg 3. And h plus is more complicated now, right? Is 1e neg 7 plus 9.23 e neg 3. What does that get? And so that's our H plus. pH then is neg log of that is what? Still 4s. What is it? Say it. 2.0. Is it that low? I'm suspicious of this one. Very, very suspicious. I don't know why. I am worried that Wolfram may be applying it to us, so I gotta go find where. So you have to start testing your assumptions here, right? So previewing the test, you're going to see nice, easy ones. Given a concentration of a strong acid, what's the pH? That should be super easy. You're going to see slightly harder as we go down to the level mid-grade, where you're looking at, here's the concentration of a weak acid, use an ice table and tell me what the pH is, right? Down to a hard question where you have to start testing your assumptions. Does that make sense? Now you know the structure of the test. But that's what's going to be on a bunch of pH questions.
So passes that are stronger, we need to assume that H plus has a concentration. That is like.
No, I think no. So ask your question again, and I think the answer is going to be no to the way you're asking it, but try it again.
So for like, I'll say this, why did we have to assume that H plus had a concentration?
Okay, that is a difficult question to answer. In this case, I suspect it is because the pKa here is on par with that initial concentration. The real answer involves when the numbers don't work out to your tolerance. A lot of times, professional chemistry, you'll say about 5% off. So if your concentration is about 5% difference, then you would not use the assumption. If it's less than 5% difference, you can probably get away. That's kind of the in practice, right? But you have to check. You have to look and see, is it going to make a difference if I do?
So should we work from that on and go back and put that over there to check? Should we use like a checking system?
Yes, and that's what we did here. Just put it back in, right? To see if it looked like it's at equilibrium. Here it doesn't look like it's at equilibrium. That's why we go back. Owen's swimming in it hard. What up, Owen? Okay. Questions back here? Miriam, did you find what you did?
I know what, like, I don't know how to do that.
Okay, I don't either. Okay.
I set it up right, but I didn't write step by step like the math. So I-
Yeah, because you set it up and then suddenly a pH jumped out and I don't know what the
Yeah,
process
I
is.
like set it up and then did everything on.
Okay, all right, y'all, that's dangerous. I know that there is like a norm of everybody just does everything on the calculator screen. Can't give you partial credit for what's on your calculator screen. It's going home with you. I have no idea. That make sense?
Yeah, like whenever I wrote it out right now, it
Okay.
actually.
Okay. Thoughts?
So you're using the quadratic formula assumptions.
Yeah.
What goes with?
Oh, okay. Which one? Oh, in the red or the blue? Okay, let's go back to the blue one, it's easier, okay? So we had, for the blue one, we had 3E, this is actually a Ka, right? Equals, we just had x2 over f minus x, right? Remember my f is this up here, right? So I'm going to choose variables here. I multiply both sides by the denominator. Then I have f minus x times Ka. Distribute that through. That means f times Ka minus Ka times x equals, still got my x squared over there, right? But your quadratic wants it all to be equal 0. So I'm going to move these to this side over here, and I'm going to get 0 equal x2 plus Kax minus f Ka. Does that make any sense so far?
That makes sense.
Now I'm going to plug in my numbers.
And then,
So let me plug in my numbers. So I got 0 equal x2, right? Plus, oh, Ka, what is Ka here?
well, 3,
3e negative 8, right? Times x. And then now I'm going to multiply them together here. 3e negative 8 and 4e negative 2. So 12e negative 12, 1.2e negative 11. Right? Okay, so my A is 1. My B is 3e negative 8. And my C is negative 1.2e negative 1. That help?
that makes sense.
Okay. You still have to just work the algebra. So you just take this right here equals 3e negative 8 right here. It's just 1e negative 7 plus x times x. Multiply. Just do the algebra on that.
Oh, is it 1e makes 7x?
1 plus x.
Oh, plus x. Oh,
Come over here and get a big Travis so you have it for later.
yeah, I couldn't see it, so I couldn't.
Yep,
see
yep.
X.
So, all right. And remember, that's an excellent break. Back me up on this. Would that be an excellent thing to take to the math lab? Yes. Yeah. They do that all the time, right? So if that is a struggle right there, if it is a struggle getting those, or getting these, or getting the implied x value from it, that's a beautiful question to be taken to the math lab. You should be doing. Okay? All right. Allison, thoughts?
You know, it's from the biggest one.
Fair enough. Yeah. Algebra is going to be a struggle, y'all. Do expect a harder with just first.
Well, question 3 and question 5 were in solution with the water. So, is there any way to know before we do, like we assume 0 and we get we plug everything back into the KA problem, and if it's not quite equal, do we have to assume 0 at first to be able to do that so that we know that we need to go back?
No,
Plug in?
you don't have to make the assumption. So,
Okay. So just do 1 -7.
yeah. Yeah, and so that's generally the approach I take, is I don't make the assumption unless I absolutely have to. So in upper levels, though, it's not always just a quadratic. Sometimes these things are third, fourth, fifth order equations that are trying to solve. And so you start looking for ways to make a simplifying assumption somewhere. Good God, how could I make this any easier so I'm not dealing with 4 imaginary solutions or whatever, right? Yeah, so, but with a simple quadratic, I probably wouldn't make the assumptions. But also, I wouldn't be trying to solve the quadratic on paper during an exam. I would be plugging into a solver or something like that. So there's also that, right? Your calculator will do quadratics. It will do solver as long as you set up one side as 0. But yours is 84 plus.
84 plus.
Okay, so it will find both solutions, but sometimes playing with the limits on it and the initial guess, you have to play with it to get it to show you both solutions. And that's kind of a proficiency using your calculator, or maybe a proficiency with algebra, knowing how to set limits, right? So Brandon, if they come to help in the math lab with that, y'all probably already know this, but basically you're playing with the domain. Okay, so solve the quadratic given this domain. And that's what the limits or the guess in that is doing in the TI. It's setting up a domain system so that it has to try to find a solution. Because it'll find one solution, like here's your solution. Yeah, but that is negative or it doesn't make any sense in my context. So you change your domain. Look, I know it's got to be 0 or greater. I know it's got to be a positive solution. And then it looks for another than that side. Stuff like that. Okay?
What calculator is working? Yeah, I've heard it.
What's your major?
I'm confused.
Ooh, who's your advisor?
My advisor is,
Oh, okay. But so, the reason I asked your advisor is because they're going to know better. However, I think for computer science, I can safely recommend the Inspire. Yeah, because it'll do so many things. Oh, okay, so you don't have a computer science advisor. You don't have an actual faculty member advisor yet. Okay, okay. Well, then I would say talk to a computer science professor. Okay, about which calculator, because they're going to know your field better. For my chemistry majors, I would definitely recommend the Inspire. Okay, because it'll do so much. It'll do See, will be derivatives and integrals for you too. So that's a good.
I'm gonna have to take calculus.
Yeah, yeah. But some calc classes,
They don't let you use those.
depends on who you have. All right. Where were we with this thing? Anybody remember? So we did all that. Oh, y'all remember that Ka times Kb gives you what? They don't remember. KW. So if I were to give you a Ka and you need to do a Kb instead, right? Well, you've got a Ka, that means if it's in water at 25C, you've got a Kb. Does that make any sense? No. All right, I'm on a race. Does anybody need this up here? Owen took a picture of it, he'll send it to anybody that asks, right, Owen? Oh, okay, maybe not.
I focused it on the thing.
Did it say? Yeah?
Yeah.
Okay, all right, good. All right. I may be getting ahead of myself, but I'll just go ahead and start. Allison, give me something with a KB value instead of a KA value. What might you be working with? What's your favorite base? Okay, fine. Sodium hydroxide, well, that's a strong. Let's not do a strong because that's too easy. It doesn't have a. Oh, how about ammonia? We did ammonia, right? Okay, so we're going to mix some ammonia in water, and I want the pH. Okay, so let's make up a problem here. So, Allison, you'll look up the KB for ammonia. So, ammonia is NH3, and I'm going to call it a base. So, what does that mean it's going to do? What do bases do in our world here? So, it's going to catch a hydrogen. I'm going to leave some space. What is it going to look like, Miriam, after it captures NH4, but the plus charge comes with it? So NH4 plus. So that's the ammonium ion. Okay, where did the H come from? I left that space over there on purpose, right? Where do we throw, Kara, where do we throw our ammonia in? What do you usually throw it in if you're going to clean with? Bucket of water, right? So what do you want me to put where then? Be bright. Keep it simple. Well, then that implies what over here now? That makes sense, y'all? Okay, but then Allison says, oh, how much do we put in? Y'all, what's our concentration in NH3? Like, how much do you throw in there to start with? You don't care, you just like take the cap off, don't it? I know, but I gotta make up a number to work with here. What molarity do you want? Very what molarity of ammonia solution do we want here? 0.4 molar. Okay, cool. That's what we put in there. Yes.
Well, it doesn't really have to be, but with the water, then react with the OH.
Well, it's where the OH, yes, it would if left alone. But we're going to find how much of it there is there at equilibrium. Okay, there will be some water. There will be plenty of water left over at equilibrium and a little bit of OH. That make sense? Okay, now, so Carson, were you asking how to tell if we can make the assumption, or Mercy, were you asking how to tell if we can make some final assumption? Okay. In this case, y'all give me 0.4 molar. I'm going to guess it's simply a fine assumption. Would be fine, but we'll check. And this is intuitive, because I'm gonna guess that the pKa that Allison's gonna give me is not real close to 7, and also, you've given me 10 to the negative 1 molar concentration, not very close to 10 to the negative 7. My guess is that it would be okay in this case. Allison? So the Kb, is this Kb or Ka? Kb equals, what is it? All right. So if we do this, 1.8 E negative. We can do this one of two ways. Let's get this thing out of the way again. And we'll do it both ways here. We could have theoretically taken some amount of ammonium put it with our water, right? And made ammonia, right? We could have done this also, agree? Should end up at the same place. But if we take the Ka of this side, Allison looked up the Kb, right? How do I get a Ka there? Kw over Kb. So 1e negative 14 divided by 1.8 e negative 5 is going to be what?
KW always 1 to negative 14.
Say it again.
Is KW always 1 to negative 14?
Here's how I answer that question, Miriam. I think I'm going to say, as far as you're concerned in this course, yes. Okay? As far as MERV is concerned in later courses, no. It is temperature dependent, maybe some other things. Okay? If you start losing your amount of water in Orgo, then it will change. You will see. You're going to see next semester in Orgo, you're going to see a 15.56. When you see that number, you should ask. But if Orgo professor does not give you a satisfactory answer, remind me. Get my email from Merv to ask me again, but I will remind you why. It has to do with concentration of water and water is 56 moles. And Merv better still have my email at that point.
You have your phone number.
Okay, see, it's not gonna change. You have the same phone number, okay, oh God. Probably since before you were born. Yeah, that phone number is probably the same. Okay, let's try this thing. So, what would we do to set up our ice table here? Marcy, what would you put where on the ice table?
0.4 is our initial range.
Okay, so I'm gonna put that there, 0.4. How about here? Don't care, right? Because it's gonna be 56 molar, right? And it's still gonna be 56 molar at the end. It's gonna cancel out. You don't care. Leave the water off, right? Okay, cool. 0, why? And put it in there, right? Let it happen on its own. Okay, how about this OH? Well, this is where you were asking, right, about making the assumption. Let's assume 0 for now, okay? If our, let's say if pH ends up is like less than 5 or greater than 9, probably okay. Does that make sense? If you've added enough acid or base to push your pH 2 pH units away from 7, that 7 probably didn't matter. Does that make sense? Probably. Okay, let's see then. What about my next line here? Cindy, are you back with us now? Can we do the next line of the ice table? What can we do here? Negative x. It's been a long time since we had a not 1 on our x's, right? Just remember that exists. If you're losing 2 protons from something like sulfuric acid, that makes it more complicated, but okay. Then down here,
0.4 subtractants.
yeah,
Which is next.
cool. Okay, now working on the KB side here on the left, right? Now I've got KB equal x2 over f minus x, right? And then if we need to solve the quadratic for Owen, right? Then 0 equal x2 plus kbx minus f times kb, right? Somebody roll from that for us. Or put in, or better yet, put it in your solver, your calculator. In this case, it was 0.4. Because that initial concentration that you gave. F stands for formal there, if you do with formal concentration. Because formal concentration is the concentration you added to it. It's the concentration you would list if you were like writing up a label for a lab or something. You would put that it's 0.4 molar ammonia. It's not 0.4 molar ammonia because there's an equilibrium concentration, but you would put that. We get anybody from the solver? You serious about it? Wow. Anybody? Nobody. Well, that's okay. Tell me anyway.
Like the fraction plus the number.
What fraction plus what number? What's it say?
-9 over a million.
What, E6?
Yeah. Plus 2.68. A bunch of numbers times 10 to the -3rd I.
Well, that's the imaginary solution. Is there another solution? So could we have a difference? Oh, Miriam, did you put in a negative value for C? Where's the with you? Not yet.
2.67 times 10 to the -3rd.
So x equals 0.67. Is that what you said?
2 points.
Oh, 2. I'm sorry. 2.67 e what?
-3.
3. Okay, and we have. Okay, so here's where you got to be careful, right? You solve for x. Don't just take the negative logarithm of that and tell me it's pH 1. Look at our ice table. We didn't solve. X is not pH. Right? X is concentration of what? Yeah, OH, so it's going to give us POH, right? So we take negative log of this to get POH, and you get
5.14.
5.4? Or what?
14.
Oh, 1.4? Okay, 5.14. Uh-oh. Greater than 5, I'm in the danger zone, right? pH then equals what? 9.86. Yes? What'd you get? That makes more sense to me. Okay, good. We try that. Yeah, it's an accurate saying.
2.57.
2.57. Also, that's happier because, right, that's gonna give us 11.43 for pH, right? Okay, that's probably accurate. What happened?
You're just saying like the X, like it had round, like there were other numbers. So like,
But sig figs, right? Those other numbers. Yeah, they're math solution, but. Right. Okay. All right, well, let's try over here now. Now wait, what do we want to do here? Careful with this one. Where's our F going to go? What do we throw in the bucket? Oh, I don't know. So, interestingly, right, it starts out over here on the product side, right? Remember that us writing it as the product side or the reactant side is just synthetic. That's our guess, okay? So, since we threw it in on this side, and if we say, oh, well, now we should say minus x over here, right? So that this doesn't go below 0. Right? That makes sense? Does it make sense? I'm listening.
I was reading it like that.
It is.
I was reading it like if you added like.
Oh, I see. I see. The way I had originally written this is that you were going to consume OHs and make H pluses, right? So since this is going to be problem, right? Negative concentration. So it's going to start working with water instead. So any negative value we get here, we can just add SOH over here. Does that make sense? Well, let's try it. Let's see what we get. So we get, what was this value here? Our Ka. Okay, so now I've got Ka equals negative x quantity squared over, oh no, that's 0.4 minus x times negative x over x, right? Actually, I can just factor out, cancel that. So Ka equals x minus 0.4, right? Ka Do we get anywhere there? Same answer. X equals what here? Or just sig base, right? It gets a different answer. Al's noticing in Harris, he does one of these problems, right? Y'all, Harris is the author that does the quant book, right? And he gets a pH of 4 one way and a pH of 2.5 the other way. Oh, pretty close. So, yeah, it really says that. That's pretty close. Some of these calculations do that. They're very sensitive. So I think it reinforces the idea that you definitely need to show me all the pieces of your work, right? Another thing to think about showing me all the pieces of your work is that, and Braden has seen this, right? If I mark a paper based on what I think to be the right answer, you know I'll recheck it. You might get right. Show me your calculations. You might convince me that I need to go back and give everybody one. Does that make sense? So definitely show me your calculations. I will take a look. Okay. Maybe. But that was just stuff. If you give me KA, we can find a KB.
So y'all get, okay, yeah, what y'all got right is go where you're, when I'm trying to solve.
I think maybe you need to be practicing some quadratics over at the.
Isn't actually things trying to put that into the job.
It is.
Scientific.
It is indeed. What calculator are you using right now? 30? Oh, no. I am not sure I agree with that. But you may be more adept at it than with the TI-30. All right. How long do we have? Not long, right? 15 minutes? No, 5 minutes. Okay. Let's figure out where we're at to pick up next time. Where do we need to pick up next time? Yup. Nobody remembered anything. These are the KVs, right? These are that idea. Look back at the KVs. Make sure you're reading the text also about KVs. Okay? All right. Remind me, please. We will start then with the theory behind stuff next time. Okay? This is just the math so far. So we can see, well, if we do this, here's the numeric value of pH that we should end up. Use a little bit of theory. It's not a deep bit of theory, but Miriam, the theory side will apply to Orgo a lot. It'll help you take some stuff away from the next level. So remind me that that's where we will start. Okay. When do we want to be thinking about doing an exam? How much do we have left? What do we have left for the semester? Not a whole lot, right? What do we have left? How many weeks do we have left? 6. Is it that many? I don't even know if it's that many now. Let's look. How's this week? Counting.
Yeah.
I don't know. They took that away? They took the calendar function away? Anyway, somebody else have all right, so how many weeks we have left?
6.
We do have 6, including this week. Or not. I can't look at the calendar anymore. Thinking it doesn't do it yet.
When is
May 1st.
Yeah. Really? They still have. So we've got, how many weeks left in March? This one. And then how many weeks in April? That, I get 5.
Yeah. Oh, no.
How did this week go?
So I kind of think we need to hurry up and get this exam in so we can start playing with electrons and thermodynamics. Well, which do you want, which do you want shorter time on, this or the next exam? Exam 3 or exam 4? Pick your poison, right? I guess that's on us, right? Yeah. All right, so think on what you have and come Wednesday ready to fight your classmates about when exam 3 is going to be. No earlier than 1 week from today. That's the earliest that I will entertain. It's next Monday. Probably no later than 2 weeks from today. Oh, Kira, okay. Do you agree that we need to get it in that soon? I think we have to. Be ready to make your arguments on Wednesday. Oh, what? Oh, yeah, but you know how I do it.
Yeah.
All right, there's another homework that's up for tonight. Take a look at it. We start titrating things. Well, it's titration.
Over what?
I don't know.
So I'm having 5 weeks in Monday.
Okay.
Including this week. So it's like, this week and 1 for 2 weeks.
The Carson definitely 14.
Okay.
But probably a little bit of fishing also. So fishing is weird because it's got the KFP stuff in it, and it's right too.
Yeah.
But it's also got more discussion of the tests.
Chapter 14.
Yeah. And then look at, no, you just have to pick around fishing. Right. But a lot of it comes from, wait, 14 is simple. If you use all 14 of it. We have not touched polyprotein acids yet. Hydration.
Just like after.
Nice.